Welcome to the Fast Mode podcast series. I'm Tara Nil, and with me today is Xenofon Foukas, Principal Researcher at the Intelligent Networked Systems Group of Microsoft Research. Microsoft creates platforms and tools powered by AI to deliver innovative solutions that meet the evolving needs of their customers. The technology company is committed to making AI available broadly and doing so responsibly with a mission to empower every person and every organization on the planet to achieve more. At Microsoft, Xenofon's research interests are at the intersection of intelligent and programmable edge architectures, systems for mobile connectivity, applications of machine learning to mobile networks, and large-scale test beds and experimentation. Xenofon joins us as part of our exclusive editorial segment on Open RAN. Welcome, Xenofon. Great to have you on today's episode.
Yeah, thanks a lot for hosting me.
Okay, great. So today's topic, we wanted to talk about Open RAN and also AI. And we know that one of the drivers of Open RAN adoption is AI. So our first question is, how important is AI in Open RAN? And how does it compare to its role in conventional RAN?
Right. So I think there are a lot of different problems that AI can solve in the RAN space, and starting maybe from the traditional problems that you had in the RAN, even in the past. And I'm talking about things like interference management, mobility management. How do you move users around to ensure that they have the best signal while they don't overload the network? All of those are problems that so far were being solved using what I call like heuristic methods, typically. But now, as we move towards 5G and beyond, the complexity of the network increases significantly. You have, base stations that have massive MIMO with a lot of antennas. You have densification of the network, more users, and all of those things mean that the traditional methods, the heuristics that I mentioned before, actually are no longer working as well. And AI appears as a great way of solving that problem because AI has this capability of dealing with, data and multidimensional problems and providing optimal solutions. So that's kind of one place where AI can play a very important role. But beyond that, in this Open RAN space, there are also changes in the way that the network is structured, where AI can play a big role, because now you have virtualization of the network, you have disaggregation of the network functions and communication through open interfaces. And even though those things are great because they can help improving the innovation and widen the ecosystem, they also introduce new challenges that you didn't have before, because before you would get an appliance as a base station which you would place somewhere, and this would be an integrated solution that would work in an end-to-end way. But now, because you have all of those different components, you have a platform, you have the functions running on top, those functions could be coming from different vendors. There are a lot of different problems that one might have to solve. Like, for example, if something goes wrong, there's some anomaly in the network, how do I know which component broke so that I know, what to pinpoint as a problem and fix it? Or now, because things are running on commodity hardware, can I somehow optimize the energy consumption of that server in a smart way? And so AI, again, can play a great role here because those are multidimensional problems. You have a lot of knobs that you might want to tune, and heuristics simply don't work that well. And finally, maybe a third place where AI could play an important role is because now the whole RAN is opening up through the Open RAN interfaces, you get a lot more access to data. And that's now important because applications that could be running on top of the RAN can actually leverage the data to add more value and optimize the network further. And here, for example, I'm talking about things like, can I leverage data that I could get from the RAN to perform a very accurate localization? Or can I sense if someone is in a room in a privacy-preserving manner without even having to look into the phone and if a connection is there? I could actually leverage data that the RAN could give me to do that. And AI solutions, again, are the key to do that.
Mm-hmm. So we are talking about data, right? So, before applying AI to data, we have to make sure that the data quality is, of a certain level, and then only you can use that as your training data, especially for your models, all the AI models. So how difficult is it to get that high quality data in today's environment?
Yeah, actually, I think that's a great question because AI solutions are all about the data. So if you don't have the right data, you're not going to get good results. And maybe if you want a problem that we have in today's networks is that the way that you get access to data is very limited. If you want, there are only very few sources of data that you can get access to. And that has been for good reasons, because if you think about how the RAN is structured, that there's a lot of different sources of data. And if you were to expose all the data you could from the network, we're talking about vast amounts of data. And that's something that immediately creates problems in terms of the performance of how you get the data out. There are bottlenecks in the network itself of how you ship the data. And that's why so far the approach, if you want, is to define maybe a few sources of data that everyone agrees that are generally useful for a lot of applications, but that doesn't necessarily mean that they're the best sources of data. And so going from that to a direction where actually you can, as a developer of your AI application, you can actually define what data you need is something that I think we're lacking and still a big challenge.
So yeah, you addressed one of the challenges that we see in this space, which is the quality aspect, right? So what are the other challenges that telcos often face, in deploying AI in an open RAN environment? Maybe in terms of data security, who's the custodian of that data? And now in open RAN, you have so many vendors, so many parties. So who's going to own that data? So any insights on that?
Yeah, actually, I think that that is also a great point, because you generate all of that data, and the question is, when you ship that, where do you ship that? And actually, the privacy preservation of the data is one of the important aspects here, and that's why one of the consideration when you're building your AI and you're deploying your AI is to know what you're allowed to do with that AI, or where should that AI live. And by that I mean, if privacy is one of the big requirements that you have, then maybe you should be deploying that AI right at the far edge, which is, something that would typically be owned by the customer, and therefore your data never leaves the premises. In other scenarios where you have more relaxed, let's say, constraints in terms of privacy, then maybe you could be deploying your AI in different locations, like, for example, the cloud. But of course, even when shipping to the cloud, there's always guarantees that are provided by the cloud that your data is not going to be used in ways that you don't really allow to.
So, what are the strategies or technologies that can address some of the challenges that we just discussed?
Right. So I think the big limitation right now is that the way that the network is designed at the moment is not a way that would allow you to have what we would call an AI native approach, meaning that when you develop an application, typically right now you have to tailor your application to whatever the network can offer you in terms of how you get your data, where you deploy your application. You're very limited, constrained in terms of how you can do the development. And so I think what we can do to help address those challenges is rethink the way that the architecture of the RAN looks like in the future to be AI native. And in that direction, we see a vision of what I would call a distributed AI RAN platform that effectively deals with all of the challenges that we just discussed. So, for example, such a platform should give you the ability to decide what exactly is the sources of data that you need, how you can get your data, how you can transform your data in such a way that will be meaningful for your application. And it should allow you to do so in a seamless, easy way. One approach that one could take there, and this is something maybe I can say a few more things about that later, that we see is that you could introduce probes in the network functions, and you can leverage recent technologies like, for example, eBPF, that allow you to programmatically tap access network functions of vendors like the DUs and the CUs, and programmatically request the types of data that you need. So this is one kind of technology. And then the other thing, which is more about where what I mentioned before, of where does your AI live, is basically what we're really lacking there is some kind of framework and orchestration that would allow you to basically deploy in a seamless manner your AI across the whole fabric of compute, from your far edge to the near edge to the cloud. And so there again, what is needed is basically technologies that would allow you to provide abstractions for a developer. So me as a developer, if I'm a developer of an AI application, I shouldn't really care about where I'm going to deploy my AI, whether it is the cloud or the far edge, and I should be able to write an application in an abstract way if you want, and then give it to a system, and that system should be smart enough to figure out where it should place my AI, and basically deal with everything else. And so creating such an orchestrator and providing this fabric that abstracts the underlying resources, I think are important things here. And there are very promising technologies, like for example, you can think of WebAssembly, which is a way that would allow you to write this kind of code that can run everywhere and could be very, very portable.
So yeah, talking about AI, and the infrastructure that we have in place, when we look at network administrators who are taking care of their networks, of the mobile networks, right? Do you think that they have the expertise, or are they prepared to work with AI? And then we know that AI is backed by complex modeling and all that expertise in the back end. So do you think that they have the expertise, or how do you guys facilitate mobile operators to make the most of AI?
Yeah, so I think that's a great question because especially when we talk about the RAN and the mobile space, the actual networks can be very, very complicated, right? There's a lot of layers, a lot of parameters, a lot of things that could go wrong or you need to tune, and getting the right experts that are able to optimize all of this is a very difficult thing to find, and therefore, maybe your average administrator of a network, sure, they will have some background knowledge on this space, but definitely you cannot expect them to be able to do everything. And it is important to be able to provide a lot of tools and capabilities that could help them in this effort. And I think AI actually, especially when we talk about Gen AI and the whole idea of LLMs, is very much along those directions, right? Because this is one of the great things that this can allow you to do. You can have your assistant that in some way will help you figure out how you need to configure your network, tune your network, give you feedback about what might be going wrong. And therefore, yeah, I think this technology fits really, really well in those kinds of problems.
And a lot of people are excited about having Gen AI as a facilitator, in between. So they don't have to think much. What they do is that just use a Gen AI interface and then type in their prompts and then get the network to basically help itself. So what's your comment on that? Will Gen AI make it way easier for people to apply AI, not just in Open RAN, but in any RAN?
I really do believe so because as you said, just this is a more natural way of doing things. I don't need to know all of those parameters and all of those things that make those networks so complicated. It's just like talking to someone and that someone helps me with dealing with those problems. And in fact, in our research, we have tried those approaches ourselves in RAN deployments, and we do see that actually they can help you a lot with your productivity, and it can help you, solve your problems in a faster way and without necessarily having to go too deep yourself in understanding what's going on. So definitely, I think this is a very, very promising direction.
Since we are talking about facilitating, right? So and you've mentioned earlier about probes, having some probes in the network. So is that provided by a third party? Would a third party vendor be able to bring in that infrastructure where they can basically read for example, the traffic flows, and be able to, provide very detailed metadata, for example, of the packets and all that, and that information goes into a data lake. So is that built in usually in an AI solution, or would that come as a separate third-party solution?
So you're asking about the probes?
Yes, the probes and any technology to monitor and to detect, say, traffic flows, and from there extract the information that is needed for the AI data.
Right. So I believe that there needs to be, at least to some extended to some level, some kind of standardization in the sense that, at least there needs to be some common understanding of where which sources you could get data from. But our view is that generally that is just a small part of it, which is, you just define the sources, but then what exactly is the data you want to extract. This is something that should be left to maybe the third party or a partner of the vendor. So basically, as long as you can provide a way of exposing raw data from their own functions, then you could have the third parties expressing in a programmatic way exactly what they need and just selecting in a filtering kind of way, if you want, what they need and store specifically for their applications.
Okay, excellent. So, coming back to Microsoft, what is Microsoft Research's role in advancing AI-driven RAN solutions? And we have heard of initiatives such as Project Janus. Can you tell us more about it?
Yeah, yeah, definitely. So first of all, Microsoft Research in general is focused on enhancing our understanding of AI and building new model architectures and exploring, how far we can push AI in order to get more benefits generally for society, but specifically in the AI run context, there's a lot of interest to see how we can solve a lot of those problems that I described in the beginning in terms of how you deal with the management of your network, how do you optimize your network, how can you add more value on applications on top, and we want to be to show how this AI native RAN vision that I outlined before should look like. And Project Janus is very much an initiative in this direction. So Project Janus, very briefly, just to explain what it is a framework that we have developed that gives you capabilities for introducing programmability in the RAN and the platform. So think of those probes that I described before. We give a concrete framework of how you could introduce such probes in the DUs and CUs of vendors, and how you could leverage those probes so that third parties can access data and build their AI solutions on top without compromising in any way the performance and the security of the RAN network functions. And so this is a framework that we announced officially in the last MWC, and it has the support and participation from several collaborators and partners, like for example CSPs like Deutsche Telekom and Vodafone, RAN infrastructure providers. You have Capgemini, Mavenir, Intel, and also software innovators. Think of Amdocs, or also startups like Cohere, Ira Technologies. And all of them have shown support for this framework because they see this value of being able to flexibly get data out of your network and building your applications without having to worry about the constraints that the current CU and DU environment gives you, which is very limited data sources and so on.
And building on that, how important is collaboration in implementing, AI in Open RAN? So you mentioned multiple parties being involved and the collaborations you have with CSPs, right? So, is it something that you do as a team together, or can we do it independently?
Well, definitely collaboration is very, very important here because you have a lot of different parties that need to come together to provide different components. So, for example, we've built this Janus framework that allows you to tap into the data, but then we need to work with the RAN and infrastructure providers, like as I mentioned before, Capgemini and Mavenir and so on, who need to integrate those probes in their functions in order to expose the data. And then obviously we provide the cloud where you could store the data and everything, all the tools that you need for running your AI. but then you need all of this innovation that again would come from third parties. Like you have, as I mentioned, Cohere, IRE, and all of those other companies that need build solutions leveraging what we provide as a framework. So I think in order for this to succeed, it needs to be a collaborative effort. It cannot be just an effort of one.
So say for CSPs who want to move ahead, with introducing advanced AI capabilities in their Open RAN, would they be working directly with Microsoft or with Microsoft and its partners? Do you bring the partners on board together, or is it something that they can choose?
I think we're very open generally in working with whatever partners might be there from the operator side. So generally, we try to expand this ecosystem as much as possible. So the more, the better, I'd say.
Yes, definitely. Brilliant. I think, we covered quite a lot of interesting topics today. And so we are now at the end of our session. Thank you, Xenofon, for your time, for joining us today and sharing these brilliant insights.
Great, thank you very much.
Okay, and I think all our listeners, have learned quite a bit on Microsoft role in this. And so to everyone tuning in, thank you guys. And if you want to learn more, visit www.microsoft.com and follow us for more updates and insights as we uncover the latest in technology and telecommunications. See you in our next episode. Bye.